Hey everybody, it's Norm from Tested.
Hey, it's Jeremy from Tested.
And welcome back to Projections, where this week we're talking augmented reality. Now, Jeremy, you and I last week went to the Augmented World Expo.
We were there last year too. It's a convention relatively new here in Santa Clara in Silicon Valley. And it's a really interesting convention because you don't see a whole lot of really common commercial products. You see a lot of really cutting edge products and companies that are innovating and making things that you haven't ever seen before.
Right, and making them not necessarily for consumers, not for things that you and I or maybe you out there would buy, but it gives us a glimpse of where some of the research is going, some of the investments are going, and some interesting non-traditional companies. Now, one company we met last year was Varjo. They made the VR-1. This is a virtual reality headset using Steam VR tracking, but their big innovation was their display system.
Right, they combined two displays into one. So the basic display is basically the same thing that's in the Vive Pro, and it provides your wide angle, your full field of view display. But in the center of that, they combine a second display, and it's a smaller physically display, but the dots are the pixels are so tight together on that it gives you like a retina resolution right there in the center of your vision. It's like a fixed foveated, but beyond what we've seen from anybody else.
Right, so there's a lot of software that's used to actually render a scene, whatever graphics engine or video, twice for the standard resolution of the normal field of view, and then, like you said, fixed foveated. And yet you could see the edges, you could see where they blend, but since checked it out last year, they have released this product, the VR-1, and have improved on that to a point where the blending is pretty seamless.
Right, and the center screen is a little bit bigger. And it looks fantastic. I mean, it looked great last year and it looks much more refined now. In fact, you need the right kind of contrast to even see where those two displays actually mesh. In normal lighting and normal things that you're looking at, it becomes invisible, and it's just a beautiful blending between the two.
So this headset, it's really made for enterprise solutions, maybe for training simulation needs, and they have partnerships where they're putting people in virtual cockpits or virtual cars to read the fine detail on dashboards. And that's where one of these partnerships has come to fruition in their new product, the XR-1.
Right, we actually tried a prototype of that last year behind closed doors, but they've finished it, and it is a pass-through augmented reality system that uses the same VR, optics and displays that they have in the VR-1, but they use a pass-through system to pass through full field of view video of your surroundings, full color, and onto that high-resolution display as well as the surrounding display.
It's something that we've seen kind of a little bit in the consumer space, like the Vive Pro has pass-through cameras, the Valve Index has two cameras on the outside, which will allow some bit of pass-through. And
the Oculus stuff already does even a more advanced pass-through, plus with the Rift S and the Quest. You're familiar with these if you've tried them. That's a black and white system, but it does give you that pass-through video that fills the field of view of the VR display.
And while that's made for comfort, we see definitely some mixed reality potential there. Mixed reality right now, with what Magic Leap's doing, with what Microsoft's doing with the HoloLens, is using actual optics, is using waveguides, and using letting you actually see the light from the real world and trying to superimpose imagery on top of that.
Which is fine, it gets you a level of comfort, right? You're not disconnected from reality, but the problem with, my main problem with that is the augmented objects are always cut off. They're always just a small subset of your field of view.
Right, and so there are a lot of potential benefits with pass-through mixed reality. Now, before we get into our impressions, I had a chance to chat with Varjo's co-founder about this technology, about how they're using it, and so let's hear that. Hey everybody, Norm from Tested here. Super excited to check in with Varjo. This is, of course, Earl. We talked with you last year about the VR-1, the first Varjo headset, and you have something new to announce this year with the XR-1, pass-through augmented reality.
Yes.
So tell me about it.
Yeah, so we're incredibly proud that we have finally achieved Varjo's vision, which is a product where you reach a level of quality in mixed reality where you cannot tell apart anymore what is virtual and what is real. And this is essentially what XR-1 makes possible. We started the proper product development phase last year and did that in close collaboration with Volvo. So we were on their test track on June of last year, almost immediately after the Augmented World Expo. finding out what you actually need to fix and improve to make it so that this becomes a true tool for the professionals like Volvo.
I mean, a car, if you're going to be in a car wearing a headset, it needs to be low latency. You need to be able to respond.
Yeah.
And I've heard that you've had people wearing this driving in public courses and closed courses.
Yeah,
with this.
that happened already in June, and throughout the year we have been driving at the kind of speeds I would definitely not be allowed to say out loud. But of course with all of the Volvo safety protocols in place, so that no harm possibly to be done.
Well, let's talk about the technology that makes this possible, and I think it all starts with the display side, which you guys, it's different than what we saw last year, a little more refined. I know you're shipping it already, but for people out there who don't understand, you get a very high resolution view of the center. It's almost fixed foveated by combining two displays.
Yeah. So what we have in here is essentially a VR1 up to the point of this barrier. So inside in there we have 2 displays per eye. Typically VR headsets have one in front of you and a lens that lets you focus on that one. We basically have an optical combiner that lets us combine a secondary screen that creates human eye resolution into the central field of view.
That 1080p, but at a very small...
Yeah, exactly. It's a 0.7 inch, like a postage stamp size display. So very small, but very high quality, of course. And now, in addition to that one, we have the best-in-class eye tracking on the unit, which allows you to do really interesting research use cases. You can remove all of the unconditional bias in any research, but you can also use it for user interactions. It's so accurate that its accuracy is smaller than an index finger's fingernail at an arm's length. And that's how accurate it is.
I do want to talk about the eye tracking because I know how you're using it in conjunction with the other end of this, which is then receiving the world information. There are 2 cameras here.
Yes.
Can you tell me about the cameras and how much data they get in?
Yeah, of course. So we have 2 12 megapixel cameras here. We're running those at 90 hertz, synchronized with the displays, obviously. And then we have a really high quality Sony sensors that take photons in. Then we send those via optical fiber cables to the PC. They are getting mixed on the GPU, sent back to the displays where the photons are getting emitted 12 milliseconds later.
From when light hits here to when light hits your eyes.
Exactly,
and that's
12 milliseconds. It's like imperceivable latency.
And that optical cable allows then you'd have a really long cable. Is it 10 meters between this?
Yeah, exactly. And this is also, again, one of the things that our customers have been asking. So we want to be able to, for example, walk around the car, or to be able to walk around an empty apartment that can be then filled with the customer's special version of the building and so forth. So 10-meter long cable makes mobility possibility even without doing a truly wireless product.
Now, it's important, of course, to have the wide-angle camera, to have as many pixels as possible. You said 90 hertz, but there's also shutter and exposure, and so how is that being calibrated to make it look like the real world?
All of that one's included, so we are running obviously quite short shutter time in here. We're talking about roughly 6 millisecond shutter time. Then all of the data transfers. We are basically doing the typical same kind of thing that CRT TVs used to be doing. So you're raising the beam, so we're keeping everything all the time synchronized, and all of the data paths have been optimized. This is the thing that has taken a year. So, and one of the things that we definitely didn't want to do is come up with a video see-through mixed reality product, which is not good enough and for professional use cases, and creates like a bad vibe to the whole video pass-through experience.
Because you don't want any motion blur. You want to see it to be crisp and sharp. Now, sharpness, that goes to their eye tracking. Are you doing, because 12 megapixels isn't blasted to your eyes all at once. That's a lot of data. How are you picking out where you want the clearest image from the cameras?
Yeah, so of course we support here also something that we have been working with a Japanese company called Socionext, the ability to grab the point that you're looking and increase the fidelity to that one, so that even though we have an optical fiber cable, we cannot stream everything from the cameras to the PC. You always
At that
get
refresh rate.
yeah, exactly. You choke down at that stage. So we optimize it so that we send 2 streams from the cameras, a bit similarly as we do for our displays.
Right.
One creates the whole field of view. The second one creates the attention spot. And now, of course, what we're able to do is that typically we run at the place where our higher resolution display is, but we can every now and then also go so that it follows your eyes, so that we increase the fidelity wherever you're looking at, and that's
also done at 90 frames a second.
Yeah.
And that attention spot, you can calibrate and configure how big that is. Like,
yeah,
I think 800
We're
by-
typically running at 900 by 500 on the focus area. Yeah,
Right.
It's a bit bigger than our focus screens in the degree-wise. Yeah.
Right, it's such a clever way. And of course, you're blending the same tech you're using to combine your 2 displays here. You can use that to blend the video.
Yes, of course. Yeah.
So you have a partnership with Volvo. Where else do you see the XR1 being used?
Yeah, so training and simulations is a huge area. So we just launched some videos of our partnership with Bohemia Interactive, who has been working with US Air Force converting T-45 cockpits to be running in full mixed reality. So you go there to the cockpit, but you don't have any plane around you, right?
Yeah.
You see the instrumentation through the video pass-through, and then what you see around you is not the room that you're in, but it's actually the world that you're flying in. Yet now you can operate all of the controls with your hands naturally, but you don't need a full laser dome around you to create a plausible illusion of flying.
And then for hand interaction, of course, you need some type of occlusion recognition.
Yeah.
I know you have the sensors built in, so what are you working on so you can actually see your hands interact with the virtual models?
Yeah, of course. So what we're doing is that we have high resolution global shutter cameras that let us capture your hands. We illuminate those with infrared LEDs, and then we additionally have a laser projector that creates a pattern so that we have an absolute depth understanding always of every piece of your hands or your surroundings.
And that's already baked into the hardware.
All of that one is here, you just don't see it because it's in infrared, so it's behind this infrared transparent mask.
Which of course you use because you're using the lighthouse-based tracking.
Yes.
So you need that type of plastic anyway.
Yeah, of course.
Wow.
Yeah.
That's a lot of tech. This is announced here. When is it going to be available?
It's going to be in the second half of this year, so we're now fixing the final kinks in the production, making sure that software is perfect for our customers, and then launch is going to be coinciding very likely with the sales start at the same time.
Awesome. Well, thank you so much for giving us a demo and chatting with us. Great to see you again.
Yeah, lovely meeting you, Norm.
So Jeremy, both you and I did the same demo. This is a partnership they had with Volvo, where we put on the headset, and the first thing they have you do is really to look around and engage with other people in the real world.
Right, they want to make a point that you can still engage with people while wearing this headset, which is nearly impossible with most VR headsets that we're accustomed to. So they put it on you, and then they tell you what you're about to see, but you're looking at them with your headset on, and you're engaging with each other. And it works perfectly well. I mean, you would expect that even going from like with one of the newer Oculus cameras, you could probably do that. But the full color does add a sense of realism. But what they do is, whereas the Oculus stuff really is just for setup and comfort, they incorporate all kinds of augmented reality into the virtual reality.
Yes, and that's the combination of mapping or just basically spacing out, designing the world. So the demo I did, not at the show, I went to see them ahead of time. They had mapped out this loft space, this office environment. And they had an open area with the steam lighthouses. And it's in this empty space, then they kind of warped in a full-size virtual car, one of the Volvos. And the cool thing they did was that they had put a light map on that based on the reflection map of what they captured from that room. So the reflections on that car were baked in, but they were accurately representing what the reflections would be like.
Was it a full-size car?
A full-size car.
So that's what they had at the demo here that we saw last week too. They started out as just a wireframe, so you could sort of almost like a hologram. And I should really point out that all other augmented reality systems that use, basically like the Magic Leap or other ones like that, they try to make their images opaque. They try as hard as they can, and they adjust the light. If they're in controlled settings, they'll give you a kind of a low light so that you can see the imagery, and it's as opaque as possible, but you can always see through it a little bit. But with this kind of a solution, it's perfectly, opaque. It's perfectly non-translucent so that you can see them. They look solid. And so when you see this hologram effect, that's sort of the starting point, but then they warp in the full car. And it looks as real as a car standing there right in front of you, with the rest of the real world projected behind it.
It was extra cool because while they had that wireframe, they actually rolled up a chair where the driver's seat would be, told you to sit in there, and then beam the rest of that car in. And because they have that high resolution center panel, looking at the dashboard elements, it was, for me, clear as day. It was it felt like I wanted to reach out and interact with these buttons and the steering wheel.
It's an uncompromised display. That center, foveated rendering in the center is really like beyond the HP reverb. I mean, it really is like this fantastic goal that I think VR is shooting for, and they've had the interesting solution of just doing it in a portion of the display, and it's quite successful.
Now let's talk about the pass-through technology as well, and what makes their solution a little different than the other pass-through systems. They're really proud of the fact that on a very low level, they're taking these 12 megapixel camera sensors from each eye and getting data through an optical cable from those cameras into the computer system and processing them at very high frame rate and very low latency.
Really long cable too. Did they say 10 meters?
It was, double the length essentially of what you could do with the standard VR cable, or with the HDMI or DisplayPort. And because they need, just like rendering the graphics on the computer to your eyes, we talk about motions to photon and movement, they need photons to have low latency as well. And I was doing the test where I was moving my hand, and I felt like could I interact with someone? You get stereo views of people, and I'd say it's good. I'm never convincing myself that I'm not looking at a display. Like, it's very clearly
definitely
a display.
Yeah, and for me, it wasn't so much the latency; it was the persistence of the pixels. Like when you turn your head, there's a blurring effect.
The low persistence of that, even though they have high shutter,
Right.
it's not low enough where you couldn't see blur.
I think that's the display itself. Like the pixels just last a while. So if you turn your head around, look in different directions, whatever the augmented, not the augmented. Things that are projected on it, but the real world is behind it, being fed from the cameras. That definitely felt like it was just, a little bit mushy. I mean, it worked perfectly well, but it's not something that is as good as your eyes.
Yes, and then your eyes are much better. What you see in the real world, and this is something that all VR makers will have to contend with at some point, is just higher fidelity than what displays are capable of today. Not just in terms of the resolution, but in terms of the color quality and also the light. Something that they have to contend with is, when I'm looking at outdoor environments, your exposure is set for maybe the outdoor environment, which may be brighter than indoor environments. And there's no real kind of HDR solution right now so that you can focus on both outside and inside at the same time. It's just like holding your cell phone or your DSLR up and you're changing exposure. And so they need to do that same thing. So you actually, when I look around, exposure is changing as I'm focusing and looking at different things.
Yeah, it's interesting that even in this headset, they don't have an HDR solution to that. I mean, this is not a consumer device, as you said. The VR1 starts at $6,000.
Right.
This is not even priced yet. So this is a high-end piece of equipment. And even for that, they couldn't source an HDR solution for that. But I do agree, like, that would be the next step. If we could actually get to the more of the sense of the dynamic range that we perceive with the human eye, that's going to be even more real.
What I also found interesting was that of the megapixels they were getting from the camera, that's so much data because they're at that refresh rate, 90 times a second. They couldn't even process all of that. Like, there's no computer right now that can do that in real time for eyes. We're doing foveated rendering for video. So they have eye tracking inside the headset as you look around.
Not fixed foveated, like for
actual
the center
foveated.
but they actually do the foveated rendering. That's awesome.
And they can do both. They can do fixed foveated because they know they have a high resolution center panel, but they can also have it so if your eye's looking off to the left or the right, they're actually going to pump more of the camera pixels into that spot. And I did a demo where they saw when my eyes were tracking, and on the computer, doing an A/B comparison, I could tell you could see more pixels. And that's essential because the people using the Varjo XR-1, the folks at Volvo, they've gone into public roads. They've driven in the car while wearing this headset.
A long way, right?
Like an hour.
That's insane to me. Like, even having, like, when you told me about this, I thought that's really compelling. And the fact that you can put augmented imagery into your full field of view, or at least your full, field of view that you're capable of seeing in VR, that's super interesting. And you could they showed videos of moose walking across the road, right? And
safety testing.
The driver would come to a stop. But the video that is projected of reality into the VR headset, that since it has that kind of latency to it and lack of dynamic range, I'm kind of surprised that people were comfortable driving a car with that display.
And this is not meant for a consumer thing. This is just
Good.
so they could test the response times in their safety testing,
Yep.
so they can test UI elements, HUD elements they're experimenting with.
Yeah.
It's cheaper than manufacturing prototype cars and dashboards to do that.
Absolutely.
And I see like this is where a headset like this could be used in research. I think the headline of driving in car with VR headset, like they have in their demo video, I think is not a practical application at all.
Right, don't try this at home.
Yeah, so interesting thing, it will be out for developers and other enterprise customers to look into and buy later this year, and they'll have pricing announced with that. But again, it just shows the power of pass-through mixed reality, which is something that I don't think should be dismissed at this point.
No, that's a huge point. I mean, the fact that we are so far away from a successful like Apple product that's augmented reality, I mean, absolutely don't sleep on pass-through as a potential stopgap, because it is really, really good. The fact that it fills your field of view, or at least the perceived one, and gives you opaque imagery are massive benefits. And yes, you do have to have a big old brick on the front of your face, but none of this is lightweight and looking good yet.
Yeah. Another future-looking technology and device that we saw also targeted at enterprise solutions was from Logitech. Yes, the makers of your keyboard or your mouse, of peripherals and speakers. They were at Augmented World Expo showing off a new device that's a pen, a stylus meant for VR. They call it the Ink Pilot Edition, and we got a chance to use it. And this looks like a big stylus, kind of like a
right, with some Steam VR trackers on the back. So yeah, this science fiction diamond shape on the back of it, right? Because that's where all the trackers are. It's still tracked in 6 degrees, and it needs to be visible by the Steam VR lighthouses. Yeah, and it has a pressure-sensitive tip. It has a touchpad on the side that sort of takes the place of the Vive touchpad. It actually reminded me a bit of the index controller because it's also vertical like that. It has buttons on the side and a pressure-sensitive button on top. So you can do a lot with it. What did you think? Did you feel like you would use this if you had a drawing app that you wanted to use? I
mean, clearly this was made for designers.
Right.
Their demo apps and the apps they had showed us were like a car creation app, using vectors, kind of prototype the shape of a car.
Yeah.
They had an app they made that was about sketching. I think digital stylus is a replacement for note-taking. It's even on iPads and the Apple Pencil, I don't find it sufficient, right? Every stylus I've had to work and retrain my hand a little bit to compensate for both the hardware and the software. How does it look on the page? Am I writing as fast as I normally would write? The latency, I think, is getting there on those, and the latency here was definitely good. The pressure sensitivity also good. It really depends on what type of application. Like, I don't know what art tools. It's a different way of thinking about art in VR, because we're so used to Tilt Brush and we're so used to Oculus Medium, and all of those convert kind of hand presence type controllers into some type of virtual tool.
Right, usually it's a brush, right? And that is the analog here, whereas what they're making is more of a pen.
It's a pen.
Right.
And their big push is that this is to get your fine motor control that physiologically we're all built with. That's why pens work. So we're doing less of this, moving our shoulders and our elbows, and more of this. And ergonomically, I really liked it.
I thought it was interesting that they're just as focused on actually drawing on 2D surfaces as they are on 3-dimensional space.
Yeah.
Because it does both. Like it has the 6-DoF tracking, and you can do tilt brush. You can draw shapes in the air and grab them and deform them. You can use a standard Vive wand in one hand, and
there's button
the
parity
ink in the other hand, and you can do things with them. But the pressure sensitivity only takes place when you're actually pressing down on a surface, right?
Yeah.
And so they actually have you calibrate the size of your pad that you're drawing on,
Right.
and then you can actually press and use this surface, and with the VR goggles on,
Yes.
right? It becomes, it treats any 2-dimensional table as a drawing pad, and that's interesting. I think that there's a lot of people who are illustrators that would be a huge, money saver for, because they're no longer using up materials. They don't have to dedicate like a space to it. It can be anywhere. It's I think it's super neat.
That's a really good point, because like on like a tablet, like your iPad or Windows tablet, where you have a stylus, you can do a lot. You can do your vector drawing, but your canvas is basically the size of the display, your tablet.
Right.
And yeah, you can shrink it and grow it. Here, the canvas is infinite, because you can look left and right, and you can shrink down as big of a sheet of paper or surface you have to draw on. That can be your digital canvas. And I went down into the details and tried to draw as fine as I could. And yeah, you get your sub-millimeter accuracy there, but I really don't think this is going to be for that. It's going to be for you to interact with other digital things you've imported into VR, and then create some type of digital sketch and export it, and then finish it in whatever tool you're used to on desktop.
We haven't seen, as far as I'm aware, any third-party Steam VR, tracked components. We have the puck, like
Yes.
the disc that they sell, but that's a first-party HTC product.
Yeah.
Besides the actual controllers and the new index controllers coming out, I am not aware of any other things besides the ink that actually went through the process of getting approved and getting the parts and being a Steam VR, peripheral. So I mean I think that's cool. Like if there's a demand for this type of thing, like they're the solution for it, and it's super neat that they took that extra step to make a proper product.
And they made it very clear that this, again, was not a product for you and me, or even freelance artists and independent artists. This is.
I don't know about that. Like I have artist friends who like buy the latest Wacom
Totally.
tablets.
I agree. Like this is not. We may want them,
Right.
but they're not selling it to those people
Right.
just yet. This is going to be a business-to-business enterprise product. They're going to sell direct to big businesses first, but I really hope that gets adopted, because I do want to see this technology trickle down. And just in terms of the VR space, thinking of VR as more a desktop experience is something we also haven't done before. We're so used to walking around and big room scale things. What does it mean to take VR and scale it back down to the surface?
I think that's going to become amplified when it gets to be augmented reality, just as much as anything else. To actually be able to draw on the surface and see the surface at the same time.
That's super cool.
That's the future.
Yeah. Those are just a few of the things we saw at Augmented World Expo. We have episodes coming down the line with more hardware demos we saw in other games as well. Thanks for watching as always, and we'll see you next time.
Bye.